Hi everyone, my name is Kaushik and today I'm trying to solve the zero lead code challenge problem. The problem is lowest common ancestor of a binary tree. So basically, what is a lowest common ancestor? Suppose if a tree has been given, suppose that is a tree. Suppose that is a tree. So if suppose telling about that. 6 and 4, which is the common ancestor. So what will do that? So 6 has two ancestor, that is 5 and 3, and the 4 has 2, 5, 4, 3. So which is the deepest? That is the 5. So that is the answer. So that in that case, if the 6 and 4 has been given, in that case the 5 will be the answer. So here 5 and 1 has been given, so in that case that will be the 3. So however I am trying to solve that. So first a dry run, then after that I am trying to make it as a coding interpretation. So first take 3, 5, 3, 5, 1, 3, 5, 1, 6, 2, 0, 8, 3, 5, 1, 6, 2, 0, 8, 0, 8, 7, 7 and 4. So what will happen that first I am trying to recursive call from that goes to there and that goes to there. So suppose that is left part and that is the right part. Suppose that that if that is not null, if that is not null, suppose that is the 5, and first I will check that if the left value is the given p, or the right value is given p, or the I mean that is the checking with that. First of all, root what is the root value basically? If the root value is basically not left value, if the root value what is the 3, if the root value is p or root value is q, I mean the two node, if the p and q has been given, so in that case directly it will be written as root, otherwise and also null in that case. Suppose first case, suppose that we have not anything, we have nothing has been present, so in that case that will be the null value, so it will be written and it will be written as root value as the null. So otherwise, so I am taking a 6 and 1. So what will do that? So 3 and 5 first is goes to there, so that is 5, and that is goes to right, when that is goes to that right part, that is right part, and right that is the value is 1, right, the value is 1, so in that case that will be written as 1 basically. So that is the root value has been given as 1, and what will happen that the left sorry, hold on, I missed there. Suppose 6 and okay, so I need that 6 and 1 basically. So what will happen that, so first we'll traverse the 3, so 3 is p or q, no, so after that will goes to left part, that is goes to left part 5, and that is goes to right part, and then goes to that goes to 6. So right now the value is its left part, it is basically the value has been found there, so it will return the 6, value, return the 6, and for there from there, that will be return the 6 value from the left part. From the left part is basically 6 from left part, and from 1, so that is goes to there. From right, when it is goes to 1, that is return 1. So left value is not equals to null, and at the root case value for the, that is not equals to null, and that is also not equals to null. So what will we do? That will be the root value will be the answer. So in that case, that will be written as 3. In that case, the return will be both the, when the both of them null. In that case, suppose in that case hold on, suppose 7 and 4, so we need that 7 and 4. What will do that? So first 3, so that is not, that is 5, so that is not, from right it will come there, that is not, and the value is become, now that is 2, from that will be the that is not the root right now. For the root left value is 7, and the right value is 4. So both of them null, both are not equals to null, I mean both of them not null. So in that case, the root value will be written in that case. So another case I have been taking there, 7 and 4. So 7 and 4, and the 5 also. So there is no right child here. So for so I need that 5 and 4. What is do? So first the left part is 4. So left part is 4. So what I'll do? That is the 4. The right part is null. So left part is 4. So 4 is matching with that the Q value. That means that 5 and 4 have been given. So matching with that, so it will directly return 4. So there will be not checking that 5 is present or not, because one of them has been present already, and because 5 is not going to there, because there is the same child, and 5's parent is 4. So it will be always 4 will be the its parent, and so this is the lowest common ancestor basically of 5. So that will be the answer. That is the 4 is basically do that. So most of the max and worst case, all have to check that all the node of their all the node has been present in that case. So basically the time complexity is order of n, and I am not taking any extra space. So basically the order of 1, but the basically the in recursive call I have been running, so that stack space, that will be the basically it will be as an order of the space complexity basically required, basically because 1 after that, because 3, first 3, then 5, then 1, then after that there is the order of n is the space complexity at worst case complexity. So right now I am trying to solve my approach as a coding interpretation. So first, if root is equals to null or root val is equals to root is equals to p or root is equals to q, in that case it will directly return root. Otherwise, right now I am making the recursive call, node star left is equals to lowest common ancestor root left p comma q, 3 node star right is equals to lowest common ancestor root right p comma q. If both of them are null, not equals to null, left not equals to null and right not equals to null, in that case it will be return root. If left is equals to not null, not equals to null, in that case it will be returned left 1. If right not equals to null, in that case the right will be preferred and otherwise return null. So let me check that if I am right or wrong. Yeah, it is accepting. So let me check another example. Yeah, it is accepting both case. So right now I'm trying to submit my code. Yeah, it's got accepted. Thank you so much.